In this video and in subsequent series of videos, I will tell you how to remember the trigonometric formulae of class 11. Number 1, we will discuss how to remember trigonometric identities that we have studied in class 10. Number 2, we will see 4 quadrants and how to remember the sign of trigonometric function in each quadrant and the range of angles. Number 3, we will discuss the tricks to remember the formula with angle pi by 2 plus or minus x, pi plus or minus x and minus x. Number 4, we will see how to remember compound angle formulas. Number 5, we will see how to remember factorization formula. And number 6, the tricks to remember defactorization formula. In number 7, we will discuss how to remember double angle formulae. Number 8, how to remember triple angle formulae. And number 9, how to remember the other formulae. And number 10, that is in the last, we will see how to remember the formulae for finding the trigonometric solutions. Now we will see the tricks to remember trigonometric identities of class 10. And to remember that, we will have to draw super hexagon, and super hexagon is a polygon with 6 sides and 6 vertices. So let me name each vertex with one trigonometric ratio. I will start with tan of theta, and we know that tan of theta is equal to sin theta upon cos of theta. And so first is sin theta, so I will write here as sin theta, and this is cos theta. And opposite to tan theta, I have to write cot of theta. That is tangent and cotangent. And then I will divide this super hexagon into 2 equal halves. Left hand side and right hand side. And on right hand side, 2 trigonometric ratios are cos and cot, both starting with C. And we will have to write the third trigonometric ratio starting with C, and the remaining starting with C is cos sec of theta. So this is cos sec of theta, and out of 6, 5 trigonometric ratios are already utilized, so the remaining, the 6th one is sec of theta. And then I have to join the opposite vertices which are already joined. And I will take this first triangle and shade this first triangle. So I have shaded this first triangle and leave adjacent triangle and go to the next triangle and shade that triangle. So here I am shading the next triangle, and after shading this, I will leave one adjacent one and go for the third one and shade this third triangle. And now I have shaded 3 triangles, and unshaded triangles are 3. I will move in these triangles in clockwise direction. So all these triangles I will move in clockwise direction, and I will start from the left vertex of the triangle and move in the clockwise direction to remember 3 trigonometric identities. So let us remember one trigonometric identity, first one, by using this first triangle. So I will start from left, and on left hand side I have got the vertex named as sin of theta. Move in the clockwise direction. Next is cos of theta, and the third vertex where all these lines join, let me name this as equal to 1. And so the third vertex is 1. Then what I will do is square all this. So this will become sin square theta, this will become cos square theta, and square of 1 remains 1 only. Then next, I will add first 2 terms and equate it to the third one. So my trigonometric identity from super hexagon I can get as sin square theta plus cos square theta is equal to 1. Let us see the second trigonometric identity. And to do that, I have to take this second triangle, and I have to start from left hand side, and the first vertex on the left hand side is 1. So I will write 1. Then second vertex is cot of theta. So I will write cot of theta. And the third vertex is cosec of theta. I will square all these. So 1 square will remain 1 only. This will become cot square theta and this will become cosec square theta. So I will add first two and equate it to the third one. And our second trigonometric identity is 1 plus cot square theta is equal to cosec square theta. Similarly, from this third triangle, I can write the third trigonometric identity, and that is as follows. The first vertex is tan theta, so I will write straight as tan square theta. Second vertex is 1, so I will write plus 1 and equate it to the third one, which is sec square theta. Now this is first formula, this second, and this is the third formula. And from this each main trigonometric identity, we will write two more formula, that is, those are the sub formula for main trigonometric identity. So let me write 1a. I will keep sin square theta on one side and transfer other things on that side. So this will become 1 minus cos square of theta. This cos square theta I am transferring this side so that it becomes minus cos square of theta. And when I put square root on both sides, this will square root of sin square theta will become sin of theta, and this will be equal to square root of 1 minus cos square of theta. And in similar fashion, I can write cos square theta as is equal to cos of theta into square root of 1 minus sin square theta. 1 minus sin square theta. And this is 1a, this is 1b. So this is main trigonometric identity, and these are the two sub formulae we have derived from the first one. And in similar fashion, I can write 2a formula as cosec square theta. When I take square root of that, it will become cosec of theta, and this is equal to square root of this side. So square root of 1 plus cot square of theta. Similarly, we can write 2b formula as keeping cot square theta on one side and taking square root, this will become cot of theta, that is equal to square root of cosec square theta, and when I transfer 1 that side, that will become minus 1. And similarly, I can write sec theta is equal to square root of 1 plus tan square of theta. This is formula 3a, and formula 3b can be written as tan of theta, and this side it is sec square theta. 1 I am transferring that side, this will become minus 1 and square root of all this. So now you see, from super hexagon we can remember the three main trigonometric identities, and from one each main trigonometric identity we can remember two sub formulae, and for each trigonometric identity there will be two sub formulae. So in all there will be 9 trigonometric formulae which can be remembered well using this super hexagon diagram. We at E-Learning Career Academy are running classes for standard 9 and 10 in maths and science, and also for standard 11th and 12th in physics, chemistry, mathematics and biology in offline as well as online mode using memory techniques. Here are the links for joining these classes. These links are also given in the description of this video.